Right, students. Good morning. Students who are in the online. Am I audible, students? Okay. So now let's start the discussion. So I hope previously we are about to start the concept of what? Come on, fast. Statistical operations. Statistical operations. Come in. Statistical operations in ND array. This Numpy. So I'll do that. We'll move to the further. How many statistical operations? 6. So next we'll go for it. On the object of, I mean, on the object of ND array, on the object of ND array, we can perform the following, which operations? Perform the following statistical operations. Statistical operations. They are, so one by one I'll go for it. So and I'll send the final documentation for you. Number one, come on, amax of, come on, next, amin of, third one is mean of, so mean of, next is median of, and next, right, next variance, and next last is what? Sixth one is standard deviation of. Standard deviation of. This is called two functions which are available. But at the same time, I already made it clear yesterday. Axis concept also I said. Axis concept also I said, students. Do you remember axis concept? So axis concept also we will discuss. Axis concept. This axis are of what? 0 and then 1. This will differ from one topic to another topic. Must be careful enough in understanding. Axis 0 in the statistical operation says what? Columns. Axis 1 says what here? Row. So previously this was different when I was doing inserting, pending and all those places, deleting. This was different. And in statistical operations, it is going to be something different. So try to remember. I'll go for the statistical operations now, students. Let us move to the place. I'll move to the Jupyter notebook. Launch the Jupyter notebook. There I'm going to take up. Let's go to this place, new, and then say notebook. There I'm going to take up. So I'll take up here statistical operations dot. I'll take it. Let us move to the further. Here I'm taking statistical operations on ND array. So import what? Numpy as what? NP. Take that one array, you take it. A is equal to NP dot array of, I'll take the data 10, 20, 30, 40, 50, 60, 70. Just take randomly if you want. 10, 15, some 4, some 20, and next is called some 19, some say minus 4, some minus 4, minus 4. Say something like, 23, and say something like 17, like that. And this is called what? 1D related information I'm taking. 1D related information I'm taking. So print this data, print of this A, and then on that I want to find out what happens. Extra bracket, and I want to find out max of 1D. So here the requirement is find maximum element from 1D. Find out. Come on, max V is equal to NP dot. Easy. This is very easy for you. A max of A. A max of A. So I'm writing print max element is equal to comma what? MV. MV. So it is going to print the max element. Max element. Similarly, I want to go for how many elements I am having here. Some 7 elements are there. Let me take 2D max also. I want to find out 2D max. So here the elements are 10, 15, like that. You take it. One more element, you take it. There is something like you take 20, you take it. Already 20 is there. You take 15. 15 is already there. You take some 35, for example. And print of that, I will do what here? Reshape of 3 comma 3. 3 comma 3. This is my matrix. Now I want to find the maximum element on this place. How do I find the max of that? So find max element of 2D. Max element of 2D. How do I find out? So I'm going to take up. So max V is equal to NP dot same. NP dot A max of what? A. A max of A. Print of what? Max V. So you try to find out the biggest element is 35. In this entire place, biggest element is like this. And how do you find the row max and then column max? Last class we did. In column max, I want to find. In this place, column max, I want to find. In this place, column max, I want to find. To find the column max of these things, to find the column max of these things, we'll go for something like this. Look at this carefully. To find the column max. How do I find the column max? Find the column max. Column max of 2D. How do I find? Column max is equal to NP dot A max of A comma axis is equal to 0. Axis is equal to 0. So column max elements. Column max elements is equal to comma what? Column max. Column max. You see that in this place, maximum elements are 23. Here maximum element is 19. Maximum element is 35. So you are getting the type of elements. Similarly, next is called what? Another one, row max. So I'll say row max here. Row max is equal to np dot a max of a comma. I'll write what? 1. So if you want, I can write it here. Axis is equal to 0 represents. Axis is equal to 0 represents what? Column max. So here what? Column max. And axis is equal to 1 says what here? Row max. So here axis is equal to 1 says row max. So row max. And just try to print row max. Any variable, no problem, you can write it. Row max elements. Here I will say row max. So I said like this and print the data. Print the data. Row max elements is equal to the first row max element is 15. Second row max element is 20. Next row max element is what? 35. So later on you would that long. Well and don't come. Not allowed. Strictly not allowed. Last 25 minutes grace period. Now it is 24, 9:24. Not allowed. Close the door. Rule is rule. So row max element is equal to this one. I mentioned it. This is the data. So next, overall together I want to print. So information about find max of max, comma what next? Column max and what? Row max of 2D. 2D. How do you find out? Print the matrix. I'll carry that entire thing. I'll carry this entire thing. Of course, from here I will carry. From there I will get it. This is the data. From this, I want to print what? All the max and min elements. I'll get it. This place. Here. Next I'll get row max also. This also I'll get it. Here also I'm getting. Axis is equal to 1, 0 represents what? Column max. Axis is equal to 1 represents this one. And max also I want to find out. The original max element also I want to find out. So here I'm finding max. Here I will carry this. Max element. Print of what? max. Max element is equal to, comma what? Max V. Max V. So try to run this data. So you are getting, this is my given data. Total max element is 35. Row max elements are called what? 15, 20, 35. Got it. And a column max also, in the column wise you see, that is also going to be like this. I think you are following me. This is about finding the max of column max and row max data. Next, I want to move to the further. Further, I just want to go for it. Now I'll go to, this is related to which function we are using? By using which function? Amax of. Amax of. So here, Amax. Same to same, I will apply what? Amin also. Amin also. And first 1D I will tell you, later you go for other things. Take the same example. In this case, find this is things like that. What is the next? Find min element. Find the min element from 1D. 1D by using which function? Come on, fast. Already there is a min. Amax is completed. Now I'll show the final syntax for you. Everything, don't worry. Min. So say here min of. So easy things. Min v is equal to np dot min of a min of a print. So min element is equal to what is this? Np dot a min of what? A. So you are getting the element called what? -4. In all these elements, what is the negative least element? -4. I hope you got -4. Similarly, if you want to find out the same thing to be getting in the form of what? 2D. If you want to get it in the form of 2D, you can obtain like this. So once you understand one thing, you can find out the min element. Can carry this, can go to this place, and you can see what is the min element in all these things. 2D also, it is going to be -4. If I want to get it in the form of what? Row max and column max. A min, min V, that is called what? Column min, A comma, what is this? Axis is equal to what? 0. Axis is equal to 0. Min element is equal to what elements? Column min elements is equal to np dot, of course, I'll write it what? Column. So here, say column min V. So you are going to get it, the column minimum values. What is the minimum value here? 10. Next minimum value 15. Next minimum value 4, -4. Similarly, I want to get it. What is the next? Row min value. Row min value, I will take it. Row min value, I will take it. Axis is equal to what? 1. So here I am writing row min. Row min is equal to, here I am writing row min. So there I will take up row min is called what? 4, -4, and then 17. This is called row related minimum values. So this is overall together, if you want all at once to place it, I'm going to write it in this place. Look at, so find min. Next is what? Column min. Next is what here? Row min. Row min of 2D by using a min of. So I'm going to write it reshape of. Now I'm writing here a min of. So I will write it min v. So I will take it column min and then row min and just take it. So I will take this min of axis and also here I will write min of. So finding column min. Next is what? Row min. So print this now, students. Min of min element. What is this now? Min v. And what is this next? Row min. Row min elements. This is called row min. And the next column min. Column min. And this is column min, and min v, row min v, and then column min v. So if you see this now, what is the overall negative element here? So least element is -4, row min elements is like this, and column min elements is like this. I hope you are understanding the importance of what? A min, and then what? A max. This is related to the concept of what? Max and min. Now I want to go for, these are very simple. Go for what? Min. See students, if you want to get it, the another kind of representation, just for a minute, just to try to follow me. I'll try to write it, this data, will carry out this, try to apply for 3D ones. 3D. 3D I am writing. I'll take it as what? 9 elements are there. I will add one more element, some more elements, 16, some 25, and say something like, some 8, something like how many elements totally? 9. One more element I will add it. Some 35 I will add it. Reshape of what I will do? 2 comma 3 comma 2, I think so. Is it clear? 2 comma 3 comma 2. Total how many elements? 4, 6, 3 plus 3, 6, 9, and 9 plus. Okay, last element I will remove. So total 12 elements. This is 12, right? So try to do this now. Try to find out this. So got it. What is this now? Got these elements. It is called two matrices are there. Each one is containing 3 rows and 2 columns. Out of that, which one is coming? Min element of all these things is coming -4. Row min it is saying. Row min. What is the row min it is saying? Take care carefully. What are the rows it is considering? One is called what? 4 -4. 1 minute if you observe it. Row min. Next line I will take it so that confusion will not be there for you. Min element, say here minus backslash n. Say here backslash n. Here I am trying to write it. This is the given data. What is this now? Min element. Row min elements is coming. What is that row min elements is coming here? It is going to give you 4 -4. And next is what? 23, 8 is coming. What is that row here? In this place, it is called treated as what? It is treated as what here? I think here we are getting axis is 0. Axis is 0. First, I will consider this part. Anything is okay, not an issue. But the column min values, I want to take it. What are the column min values here? If you observe it, in this column, in this column, in this column, in this column, you need to take care. What is this in this column? What is the minimum? Come on, fast. 4. But where is that 4? It is going to be something looking, I think, 10 is coming and 15 column min elements. In that it is going to give you, I think, 4, and then what? Column min elements, it is going to give you what? First part only it is giving. It is giving you column min elements. It is giving which elements? First matrix only printing. Here, axis is equal to 0. A of axis is equal to 0. Column min. It is going to give you. Yes, got it. 1 minute, students. Next about this place, if you look at 15 and then 15 and then what? 16. 15 and the next is called what? 16. 15 here and then 16 and then -4. 15 and 16 and -4. But what is happening here? 15 and 17. Okay, I'll explain you. Just give me. Come to the point of it. You take this data, you take this data, and you take this data. Take this column and this value. Are you following? What is the minimum? Come on. What is the next 4 and 35? 4. Next 19 and then 25? 19. Okay. Next is called what? 15 and 17? 15. Next 20 and then 16? 16. And the next minus 4 and 8? This is called what? Column min. In where? 3D. In 3D. Very, very, very important. So remember this data. That is what the data I'm going to show you. This is the data what we got it. Did you understand? That is the one. Don't get confused. Be simple in understanding. Similarly, go for what? I think it is reversed or what? Column min, you got it. Next is called what? Row min, I want to take it. Row min. What is coming here? 4 and minus 4 is coming. What is the 4 and minus 4? This is called what here? This entire place. What is considering here? 4 and minus 4. 4 and minus 4. In the first matrix, 4 and then minus 4. And in the second matrix, 23 and 8. 23 and 8. It is considering about, I think, here 4 and minus 4 is coming. It can be taken as what? In these places, row is coming. In these places, what is coming? This is, I think it is getting reversed, right? Variables, let me show it now. Axis is equal to 0 represents what? Column min. This 0 represents this matrix. And here it is going to be like this. In this place, what is happening here? In this place, you are supposed to get it. Yeah, it is reversed, I think so. It is getting reversed, I think so, students. Is it getting reversed now? So I will take it. Here I will take it. Row. Don't feel difficulty, students. Because if I don't show this 3D, if I go for only 2D, because everything was happy. But you have to go for what? When 3D coming into picture, you have to careful. Let me cover that also. Let us try to understand. Even if you look at for this entire thing, even in specification also you will not find. Even in any website also you see you will not find this. And don't get any tension of here. Let me go for, I will prepare it and carefully try to follow. So here a row and then what? Min. I'll write here a column min v and row min v. Try to execute once and then see. So column min, what is the answer is coming? 4 and minus 4 is coming. Yes. Next in this case, what is coming? 23 and 8. Okay, that is also perfect. In this place, what is the row minimum? 10. In this place, what is coming? It is taking in this place column min, okay. But here row min time also what is coming? 10, 15. This is also considering this only, students. 0th first one. Just for a minute. When axis is equal to 0, when I say, what is the value considering? Just a minute. I say axis is 0. Both of them I'll say axis is 0. And try to see once. What are the data coming here? Both of them same. Let me write one here. One related row, one related min of axis is 0. Axis is 1, column. 1 minute. Row min. Row min. Row min, axis is 0. Row min, axis is 1. Row min, what is an axis here? 0. Row min, axis is called what? 1. Axis is 1. So both of them I will write row min. See that getting the same. Here also we are getting the same answer. I think I need to mention here 0th matrix, first matrix, and a 0, 1, 2, 0, 1, 2. There is some concept is there, student. There is no doubt in that. This is called what? Matrix ID. This is a matrix ID. In that matrix ID, 0th case, what is I want to consider? Rows I want to consider, columns I want to consider. In this matrix ID, rows I want to consider, and then what? Columns I want to consider. But in this case, what overall together is coming? Both of them are giving what to us? Column related max is only coming here. And don't mind, can you give me some time for me to explain you? In further class, I'll prepare it and I will explain it. Here in this case, both the answers are same is coming. Next I'm going to take up in this explanation, instead of making you to get confused, next I will go for giving you separately. Okay, now if you separate it, you will get it. You say, for example, A of 0. What is this A of 0 will give you? One matrix that we already understood. It is nothing special about us. It is very straightforward. It is a straightforward. Here you already learned this. A of 0 says what? First matrix. First matrix is what? This place. What is the first matrix max min element? -4. What is the row minimum in axis 0? What is the row minimum? If we go to this place, A of 0 place, if we go to this place, A of 0, if I go to this place, if we want to separate it, print of what? Row min elements. Row min elements in where? A of 0. That means first matrix in that. Comma, what I am saying? Row min. Row min. So got it what here? Row min V. Yes. Row min V. So you got it what? What is that I am getting? 4 and -4. A of 0. It is giving columns. Right. What should I say? 1. So what is that I got it? 10, 4, -4. That is very clear. Correct. Very clear. Now, similarly, if we want to go for what? Columns. Columns also if we want in the same mechanism. Column. Column min. No more confusion. If we want like that, it is very easy. What is this now? 0. I will take up. What is this now? Column min. Column min. Of what is this now? Column min. Column min. I'm going to take up. Here you see the column min. What are the columns here? 4 and then what? -4. And row related 10 and then what? 4 and then what? -4. That is no issue about it. Are you following that? And a min also, if you want to get it, you can get it. What is that now? Min is equal to what? NP dot A min of what? A. A of what? 0. Of 0. This is straightforward. Here nothing special about it. My intention is min element. Min element is equal to what I'm trying to write? Min. I'm writing. Min element in where? A of 0. A of 0. This is the one I got it. What is the min element in the first matrix? -4. This is straightforward in the first matrix. Now, this is one way, students. But my intention of first one is different. This is called another type of mechanism. What is the next one? Same thing. Copy paste. What should I do? Yes, A of 1. A of 1. Here also A of 1. Here also A of 1. All the things go to that minimum value I am getting. Axis is 0 and 1. Same thing. A of 1. Here also. Here also A of 1. Here also A of 1. A of 1. So here I am going to take up. This is related to what? A of 1 is minimum element is what? 8. Next is called what? Row min element. What is the row min? 17, 16, 18. Got it. Column min element is what? 23, 8. You got it. But my intention is not like this. This is nothing but 2D only now. But my intention is what? Overall matrix I want. You give me some time because it is not a on spot weekend. If you want to go for it, if I want to explain only this was already cool. But I want to tell you that 3D concept also. That part I will explain in the next class by seeing the specification. How to do it. Because there is a concept of what? Z-axis is also coming. Z-axis represents what? Matrix ID. And in the particular matrix row, in the particular matrix column also I need. That's why actually we can find out like this, which is very cool, not a difficult about it. But my intention is overall 3D I want to find out. For overall 3D is concerned, let me see the specification. Let me work out on that and I will come to know. Okay, students, online students, I think I did not confuse you. I think I did not confuse you. Okay, I think it is clear. Go to that. Next one is called what? Mean. I will go for it. Mean. Mean. I'll go to the mean. So go to the next one. Find the mean. Find the mean of what? ND array. First 1D we will go for it. 1D. So how do you take the data? By using which function? Mean function. Mean function. Simple. NP dot array of what? NP dot array of take some data 10, 20, 30, 40. This is a data. Now print of A. Now you can find out mean value is equal to NP dot. What is this now? Mean of what is this? A. And print of what? Mean. And you know already mean of A is equal to, I need not to tell you, 10 plus 20 plus 30 plus 40 by 4. 40 by 4, number of numbers, which is nothing but almost what? 100 by 4. 100 by 4 is nothing but what? 25. 25.0 you will get it. So I'll write it what MV. So you are going to get what? 25.0. That is 1D. It is a straightforward. Go to the next point. Find the mean of. Next approach. 2D. Find the mean of 2D. Average if you want to find out. Go for that. Take it as NP A is equal to NP dot a range of take some data. Something like 10 comma something like I'll take it. How do you take it? Dot. What is this now? Reshape of some 3 you want. What is the 3 I want now? Something like 3 comma 3 I want. 3 comma 3 I want. What I will do now? 3 into 3. 9 I can say. Print of what? A. Print of A. This I want to find the mean. Finding the mean is nothing but finding the average of all these numbers. In the beginning core Python level only we did this now. Is it not finding the natural number sum? Natural number sum. How do you find out? Come on. MV is equal to NP dot mean of A. Mean of A. and print of what? Mean is equal to, mean is equal to, now I'm writing what? MB. So print this data, MB mean is equal to what? 4.0. 4.0. Are you able to follow? Right. Next, I will go to the, similarly to that, I will find the column mean as well as row mean also. What is the column mean? 0 plus 3 plus 6, 9 by 3. What is the answer? 0 plus 3 plus 6 by 3, 3 rows, 3 rows. What is this now? 9 by 3. What is this now? 3. So 3.0. Our next column is what? 1 plus 4 plus 7. 12 by 3. What is that now? 4.0. Next is called what? 2 plus 5 plus 8. 15. 15 by 3. 5.0. What does this mean? Column mean. Column mean. Row mean, please. 0 plus 1 plus 2. Come on. 1. 1.5 or 1 now? 1. Next, 3 plus 4 plus 5. 12. 12. It is called what? 4. 4. 6 plus 7 plus 8. 6 plus 7 plus 8. 21 by 3. 7. This is called what mean? Row mean. Row mean. So say, so column mean value is equal to, first, NP dot mean of A comma axis is equal to 1, 0. Next I'll say print column mean is equal to, what is this now? Column MB. So you will be getting the data 3, 4, 5. 3 point means what? Integer. 3 point means what? Float. 3 point. That is 3.0. Similarly, I'll go for what? Row mean. Row mean I will take it. Row mean value. So I'll take it. Row mean value. Axis is what? 1. So here I will write it. Row mean is equal to, so I'll take it what row mean value. So I'll write it. See this data. See this data. You are getting what? 147. So the overall together, if you want, I can go for taking, finding the max of it. Go to the place, 2D, and the given data. Find directly, what is this now? Mean of A is equal to, how do I write it? NP dot mean of A. And similarly, I'll go for what next? Row mean or column mean is equal to, axis is equal to what? 0. And next what? Column mean. Row mean I will take it. Next is called what? Row mean. Axis is 1. So try to print this data. You are getting the mean is called this one. Row mean and then column mean is coming. This is for what? Come on. 2D. 2D. Same thing you can apply for what ND. That ND I will tell you one standard formula for you. Then we can apply. Right now don't worry about that entire stuff. 3D also I will go for telling the mean. So let me prepare one standard format for you. So this is comes under 2D related mean. Go to next what? Median. It's an important students. Try to take care. Median I will go for it. So finding the median. Finding the median of what? 1D array first. What the median concept says here? What the median concept says here? When data is given for us, when the data is given for us, first you need to keep the data in which order? Sorted order. First, median concept says that whatever the data which is available, keep the data in which order? Sorted order. And that sorted order data, take the center element. Take the center element. Take the center element. And that center element will become what? Median. Median. That too, if the number of numbers are odd, number of numbers are odd, number of numbers are even, that time the center element will become something different. For example, if I take the elements called 10, 4, and 15, and then 6, and then something like, 4, something like, 7, if I take it, how many elements are there? How many? 5. Sort these elements. When I sort these elements, what is this now? 4, 5, 6, 7, and next is what? 15. 15. How many elements totally? How many elements totally? Come on. Right. The center element is becoming what? 6. The center element is becoming 6. Are you able to follow? That 6 is becoming what here? Median. Suppose if there is another element called what 14 is there. What is the data here? 4. Next is what? 5. And next is 6. And 4, 5, 6. 5 is there. 5 is not there. 4 is there. Next is called what? 6. 4, 6. Next 7, 10, 14, and then 15. And next, how many elements? 6 elements, right? 6 elements. In the 6 elements, what is happening? Center 2 elements are what? 7 and 10. You add them. 7 plus 10 by what? By what? 2 you need to take. 17 by 2 is going to become what? Median. That is called what here? 8.5 is called median. So I hope you are following that. What is this concept says? Median is going to be calculated in 2 ways. Number of numbers are even, number of numbers are odd. I'll tell you that entire description in the class also. So go to the example here. A is equal to np dot array of, take some data, 10, some 5, and some 6, and some 15, and then say some 20, and say something like 8. This is my given data. How many elements here? 6 elements. Take one more element called what some 3 you take it. And then print of A. Print of A. Close this bracket and print of this A. When I print this A, what is happening? This is the data printed. Now sort this data. Now I am finding median value is equal to MDV is equal to NP dot. What is this? Median of. What is this now? Median of says what? A. What is this data sorting? Keep the data in the sorted ones. 3, 5, 6, 8, 10, 15, 20, 20. So total these 3 elements and this side 3 elements. What is the data becomes here? 8. 8 is becoming what? Median. 8 is becoming median. So median is equal to writing here. Median is equal to comma what? MDV. MDV. So this is called what? 8. Very, very important. If I take the elements called what? One more element you added. Say the element called what some 7 you added. What is the sorting of the data? 3, 5, 6, 7, 8. Next 10, 15, 20. So these 3 elements one side, these 3 elements one side, 7 and 8. This 7 and 8 is called what? 7 plus 8 is called what? 15. 15. 15 by 2 is called what? 7.5 is called median here. So try to print it. Try to print this MDV here. So write it. So 7.5 is called what? Median. This is for what? 1D related. You can go for what also? Come on. 2D also you can apply. 2D also you can apply, students. Let us move to the further. Finding the median. Finding the median for what? 2D. 2D. With what? With a row and then what? Columns. So take this data. Take this data. How many elements here? How many elements? 8 elements are there. So 8 elements. What I will do now? Reshape of how many? I will take it 2 comma 4. 2 comma 4. That is the 2 rows and 4 columns. If you print it, so elements is equal to, now I'm writing here of what? A. So I'll say this data. For this, I want to find the median as well as mode. Median I want to find. How do I find out? There only you try to say. I'll take this data, find out. Come on, fast. MDV is equal to NP dot median of A. Next is called what? Column median is equal to NP dot median of A comma axis is equal to 0. Next, row median is equal to what is the next axis is equal to what? 1. This is a row median. So now I want to print the data. Print of what? Median is equal to comma what is this? MDV. Next is called what? Print of what? Column median. Column median is equal to what? COLMD. Next is called what? Row median. Row median is equal to what? Row MD. So print this as you know already. Here, if you take it median, anyhow you calculate it. Now you go to this 10, 20. This data is sorted only. What is this? Two elements are there. 10 plus 20 by what? 2. What is the element? 15.5. 15.5. Column I am talking. 8 plus 5. Mudhubavulu palakanda. Calculation also don't know. 8 plus 5. What is this? 13 by 2. 6.5. Next is 6, 3. 4.5. Next is what? 15 and 7. 22. 22 by 2. 11 point. This is for what? Column. Row 1, you are going to get this row 1. 4 are there now. 4 means what? 5 plus 6, 8 plus 3. You need to do that calculation. So I hope you are understanding. Median as usual earlier, and this is a median, you got it. If you speak something, you will get it. A red shirt student, just yourself. Red t-shirt. Yes. Completely watching like a doll. Stand up once. 8 plus 3 by 2, how much? Huh? 11.2. 8 plus 3 by 2, 11.2. 11.2. 11 by 2. What is the answer? 11 by 2. Even I also says. So you have to say that. Try to use out. Stand properly first. Try to not like that. Speak out something. Sit down. So are you able to follow this now? This is 8.3. It is done. And it is called what? 11. And you are going to get the data. So here mean is going to be, median is obtained here. And similarly, I'll go for what? 3D mean also will be there. 3D mean also I'll prepare for 3D previous standard formula I will tell you and I'll give you that. So in overall sense, I took it as what? Odd number of even number of columns, even number of rows. Similarly, if we go for all over together in a quick manner, if you take it, the same data, if you take it, here I'm going to write it. Understand here always. My dear student, I already said to you, always result is coming in the form of float means what? I already said in the class, float 64, float 32. I already said in the LKG level only. And especially we need not to worry about float 64 and all. Already said now? Already said. Go to the data. Here I'm going to take up. Carefully follow. 10, 20, 30, 40, 50, 60, 70, 80, 90. This is my data of what? 3, 3. 3, 3 you take it. It is a 3 by 3 matrix and I want to find the row, median and everything here. What is coming? What is the center element? Total how many elements? 9. 9. Data is by default. I gave the data in sorted order only. So 10, 20, 30. You think in the form of flat format. Exact center element will become what? 50. 50. That 50 median is coming. You go for this now. Column you see, columns you see. What is the column now? 40. 40. This is first of all sorted or not? 40. This is also sorted or not? 50. This is also sorted 60. Next, go to this place also. What is this now? 20. Also 50. Also what? 80. In a quicker manner. This is the first one is called what? Even rows, even columns. Here also what? Odd rows, odd columns. This is the data. I think you are following me. What is this median? Generally, most of the time you will come across up to 2D level, but we need to learn 3D level also how to deal with it. That I will show you proper explanation for you. So something is a something is skip off from my brain. I'll show you in the next class only. I'll show you compulsory. Next, go to what variance I want to go for it. Variance. What is this variance? Take a small example. Take a small example. Variance is nothing but difference between two consecutive numbers in the distribution of the data. Suppose in your class, the people are getting the date values like what? 100, 99, 98, 97, something like 19, 99, 98, 97, 96, 98, 99, 97. Like that, so much of volumes of data is available. What is the variation among all these values? A variance, I want a variance means what? Between two values, what will be the difference? What a standard difference of all these things, not only between these two numbers, the overall difference, overall variance among the people. Suppose some people are getting 100 marks, some people are getting 40 marks, some people are getting 60 marks, some people are getting 90 marks, some people are getting 20 marks. Variance is more or not? There is a lot of variance is there among them. Are you getting this? So that variance, if you want to find out, I will go for the formula here. What is the formula, students? Please look into that. This is my given data. Given data is indicated by what? Xi. Xi stands for x1, x2. There is a x of 0, x of 1 like that. A of 0, A of 1 like that. Xi minus what? M. That is called mean. Mean. Whole square to the power of by what? Number of numbers. This represented as what? I is equal to 1 to n. Summing. This sigma indicates what? Summing. So xi minus m, mean whole square by what? N. This is a formula. I will use that formula now. Try to follow. I'll take a small example. Then I'll move to the further. Take an example here. Finding important. Finding variance. Finding variance for the for the following sample distribution, sample data. So I'm taking A is equal to np dot array of, I'm taking 2, 1, 4 and then 3. Small data I will take it. Dot what I am taking? Dot I am taking. Okay, I'll take it. First you take this one. What I'm going to take it? Print of what? A. This is my given data. What I want to find? Variance I want to find. What is the variance you will get it? What is the variance formula I said? Xi minus m whole square by what? Number of numbers. Whole square by number of numbers. How do you find the mean? How do you find the mean? M is equal to np dot what? Mean of what? A. 2 plus 1 plus 4 plus 3 by what? 4. What is the answer? 10 by 4. What is the 10 by 4? In the stand up. Back side. 10 by 4. తెలియదు మళ్ళీ ఉత్త కూర్చున్నావు బటన్ పెట్టుకో 10 by 4 is called how much? 2.25. మాట్లాడు. When you speak something, you will get it. When you sit statue, nothing will come. Sit down. 2.25. 2.25. 2.5, 2.5. 2.5. 2.5 is going to be like this. 2.5 is the mean. Print of what here? M. 2.5. Now, that 2.5, mean I got it. I am using what? 2 minus 2.5 whole square. 1 minus 2.5 whole square. 4 minus 2.5 whole square. 3 minus what? 4.2.5 whole square. Are you following this? So how do you write it? This is x1, x2, x3, x4. What is the mean here? 2.5. How do you write the code? How do you write this now? Already formula చెప్పాను కదా. Sigma I is equal to 1 to n xi minus m whole square by n. So calculation starts. What is the x1 here? What is the x1? 2. 2 minus 2.5. 2 minus 2.5 whole square. Whole square. Plus, I'm going to take it. What is the next xi? 1 minus 2.5. 1 minus 2.5 whole square. Whole square. Plus what next? 4 minus 2.5 whole square. 2.5 whole square. Plus what next? 3 minus 2.5 whole square. 2.5 whole square. By what? 4. 4. What is this answer now? Here 2 minus 2.5 whole square means 0.5 whole square. Minus 0.5 whole square means 0.25. 0.25. You don't try to see only by opening your eyes with 360 degrees. Speak out. At least speak out or some answer will come. Next plus 1 minus 2.5 minus 1.5. Minus 1.5 into minus 1.5. 2.25. Sorry is looking, don't act as a Tamil actor. Sorry is looking, something saying movement of lips means I will understand what the answer you are saying. Right, 2.25. Next is called what? 4 minus 2.5. Same 1.5 whole square. That is also called what? 2.25. 2.25. 2.25. Plus what next? What is that? 3 minus 2.5. 0.5 whole square. That is called 0.25. 0.25. Tell me now. Answer you tell me by what here? By 4. What is the answer now? Tell me. 0.25 plus 2.25, 2.25, etc. So 4.50 plus 4. That is called what? 5 by 4. 5 by 4. 5 by 4 is nothing but what? 1.25. 1.25 is the variance among all the distribution of the data. 1.25 variance, the total people are varying the values. Are you able to follow this? So now I am going to use it. This data, I want to find the variance. What is the variance now? 1.25. V is equal to NP dot variance of A. Directly I am printing. So V I am printing. What is the answer now? 1.25. The concept behind this 1.25 is nothing but I shown you that. That's the way you need to find. So I have some large samples of data. What is the variant? What is the variation between among all these people? What is the variance in marks? I want to find out. I will go for this. Are you able to follow? One student got 100 marks, one student got 20 marks, one student got 40, one student got something. Is it variance will be different or not? So that type of thing you need to understand. Okay now? So try to move to the further. What is this variance is finding like this? I want to find the variance in where? Column also, row also. Shall I go for the things total? Go for this entire thing. Directly I will write it. How do I write it? Written. Now directly I will mention it. All the things I will write it here. Come on, print of what? Come on. Variance. Variance is equal to variance of A. Variance of 2D is equal to what? Comma. NP dot variance of A. You got the variance called 1.25. Immediately you go for what? Print of what? Column variance. Column variance. Column variance of 2D is equal to, come on, NP dot variance of A comma axis is equal to, come on, 0. 0. What is the column variance here? Of course, 1 minute, ma. 1 minute. I need to say what? Shape of 2 comma 2. Shape of 2 comma 2. Whether shape of 2 comma 2 or 1D, answer is same only. First you check it out once. Reshape, yes. Yeah, reshape. So I'm getting what? The answer is going to be same. Now I'm going to apply what kind of thing? Column variance. What is the column variance now? First of all, what is this column now? This is a column or not? What I want to find out? 2, 4. 2, 4. What is the 2, 4 mean? What does the 2, 4 mean? 6. 6 by 2, how much? 3. What is the formula? 2 minus 3 whole square plus 4 minus 3 whole square. By what? 2. Minus 1 whole square means 1. 4 minus 3 is also 1 square means 1 by 2. 2 by 2 is called what? 1. So I will write 1 point, comma, 1 and 3. Come on, 1 plus 3 by 2. 4 by 2 is called what? 2. 2 is the mean. 1 minus 2 whole square. Come on. 1. 3 minus 2 whole square. 1 by 2. What is an answer? 1 point. 1 point, 1 point is called what? A column. Are you getting? Yes. Next row. Row. Let me show you that. 1 point, 1 point is called variance. Next. Come on. Row. Row. Row variance. So I'll take it row variance here. Same to same. What is the row variance? This is called what? 2 plus 1, 3 by 2, 1.5. 2 minus 1.5. 2 minus 1.5. 0.5 whole square. 0.25. 0.25 plus. What is the next? 1 minus 1.5 whole square. 0.25. 0.25, 0.5 by 2. This is 0.5 by 50 by 2. What is the answer? 0.25 is one value. This is for this 0.25. Same next. 4 plus 3, 7 by 2, 3.5. 4 minus 3.5, 0.5 whole square, 0.25. 3 minus 3.5, 0.5 whole square, 0.25. 0.25 plus 0.25, 0.50 by 2. What is the answer? Huh? 0.25. What is the answer here? 0.25, 0.25. This is called what? Row variance. Are you able to follow? This is called row variance and then column variance we got it. This is related to the concept of what? Variance. Any difficulty? No difficulty. How the variance formula? I'll show the variance formula also for you. Variance formula, I will open it and I'll show you that. Next, standard deviation. Standard deviation will be very simple. What are the variance I got it here? What are the variance? What are the variance I got it here? 1.25. Generally, for one thing, I'll show you here. Variance for the normal data is called what? 1.25. 1.25 is square root. That is a standard deviation. If you want to express the variance in terms of square roots, you can go for what? Standard deviation. 1.25 formula. 1.25 star star what? 0.5. And without using square root of, I can use this type of formula also. Are you following that? So try to get it. Here also, I'm trying to get this. Here I'm going to get it. Finding standard deviation. Finding standard deviation. Standard deviation. Standard deviation for the following sample data. Print A. Print of what? Variance is equal to NP dot what? Variance of A. And next print of what? Standard deviation is equal to. Standard deviation is equal to. What is this now? NP dot standard deviation of A. Standard deviation of A. What is the answer is coming? 1.25. Square root will be coming. 1.25 square root. If you want, you can test it. 1.25 star star what? 0.2. What is the answer is coming? Here the same answer is coming or not? Same answer. I hope you are understanding. Standard deviation is equal to square root of what? Variance. Don't get confused in square root which is applied. So the difference of the samples of data can be expressed in two ways. One is in the form of what? Variance, and you can express in the form of square root of variance also, that is called standard deviation. Are you following? You can express a number in terms of normal, you can express in squares, you can express in square roots also. It depends on how you apply it. This is about the standard deviation of that. Let us go to 3D related. 3D related, you take it. The same example I'm going to apply for 3D. So go to the place here, find the STD for the following sample data. Variance is coming. Similarly, I will go for what? Variance and standard deviation. Variance and standard deviation. Same to same, I will write it here. STD of 2D. Column standard deviation. Column standard deviation of row standard deviation of 2D. I will write it STD, and here I will write it STD. Here I will write STD. Here I will write STD. Same, whatever is there, it is very simple. Everything is readily available. And as I said to you, 1.25 square root is this. And then 1 square root is also going to be like this. 1 square root is also going to be like this. 0.25 square root is what? 0.5. 0.25 square root is called what? Yes. If you want 1 square root, and see this now, 0.5, it is called 1.0 only. And 0.25, 0.25, 0.25 is called what? 0.5. I hope you are understanding the meaning of what? The standard deviation formula. Are you following? And here there is a no, and I am writing one note here. Numpy module does not contain mode. Mode function is not there. But there mean is there, median is there, variance standard deviation. Which one is not there? Mode function is not there. So mode function present in where? Statistics module. Statistics module. It is present in statistics module. It is not present into where? Numpy. Take an example of it. I will take one example. So here A is equal to, first of all, what mode will give you? Frequent occurring element number of occurrences, whichever is coming. Highest element occurrences. Whoever is having highest element occurrences, that will be given. So here I am writing np dot array of, saying here 10, 20, 10, 10, 30, 40, 10, 20, again 10, and I will write 50. This is my data. I am writing print of A. This is my data. And np dot mode of, what is this? A, error. Attribute module numpy has no attribute called what? Mode. It is not there. Where is that mode is available? Statistics module. So here I'll keep it. Here I'm writing error, it will come attribute error. Now I'm going to take up statistics. Now I'm going to take it statistics module. Come on now. Come on fast. What is this now? Import to statistics. Import to statistics as what? Yes. Statistics. Import to statistics as what? S. Statistics as yes. What is the statistics? Python module, not NumPy related module. NumPy does not contain what? Mode. Statistics is a predefined module of Python only, developed by Rosum. There I will take it. Go to the place of it. Here I am going to write it. Here I am going to take this data. Here I am going to take this data. You observe it. Now I am going to take it what? Yes sir dot. Come on, what is this now? Mode of. Yes sir dot mode of. A I need to pass it. A I need to pass it. What is the mode? 10. Because the 10 is called most frequently occurring element. Able to follow? So, suppose how many times 10 is available here? 5 times. For example, one more thing. See that. Very carefully try to observe. Here I will write it. Here 1 time, 3 times, 4 times, 5 times. Here I will write it 20 also, student. 20. 20 is available how many times? 1, 2, 3. And one more time also I will write, one more time also I will write 20. So equal number of times I'll write it. What is the equal number of times? 10, 10, 4 times, 20, 20, 20, 20. Still, what is the first in order? 10 or 20? 10. So what will come here? Of course. What is this now? Print of what? Mode is equal to A dot NP S dot mode of A. Mode of A. What is the answer? 10 is coming because 10, 20 also same number only. But which one is in first? That will be coming. Next moment you see, students. Next moment you see. Here I am writing 20 here. I am writing 10 here. What is happening now? 20 will be coming. But both of them are having equal number or not? That time you have to go for multi-mode function is there. What is the function name? Multi-mode. So here mode is there, which is giving single element. S dot multi-mode. Multi-mode. Multi-mode will give you what? What are all the number of elements? Equal number of times are there. Both of them will come. So here how many things will come out? 2. 20 and then 10. So see the data 20 and 10. Are you getting? Suppose if there is one element called a 10 extra, that time only 10 will come. That time only 10 will come. I hope you are following me. Only 10 is coming because 10 is having more number of elements. Are you following this multi-mode? So how many functions are there in statistics now? Mode, multi-mode. What is the difference between mode and multi-mode? Mode will give you highest number of occurrence element. Multi-mode will give you equal number of occurrences are there. All of them will be coming into picture. It is not only to be applied on ND array, students. You can apply on what you know. Normal list also you can apply. This is my list data. On list also you can apply. Print of A. S dot multi-mode of that. So A equal to, yes. A equal to. So you can pass the data and get it. You can get it. Even mode also you can apply. Mode if I say only one is coming. Only one is coming. I hope this is mode is equal to like this. Only one element is coming. Are you able to follow this? So mode and then this kind of thing. Wait, where is the mode is available? In statistics module. Not present in where? Right. So if I go to the place, I want to show you the final documentation which I want to tell you. So here I will take it. Statistical functions here. One statistical functions I will tell you. Here I'm going to tell statistics. So here I'm saying statistical operations you see. Here I'm having a small, this is the one I'm telling to you. Amax, amin, max and everything. You see here, these operations we can perform on the entire matrix. We can also perform on column wise and on what? Row wise. Amax, this function obtains maximum element of that. Syntax number 1, syntax number 2 with access, syntax number 3 with access. Obtain max elements on the basis of columns. Obtains max elements on the basis of what? Row. And I give some examples also here. You try to go through it and you have seen the example. Min also, are you seeing that? Min also with what? Axis wise I said. Overall matrix I said. Example also given. Mean. What is the mean? Mean of the total matrix elements. You can find out on 1D and you can find out on 2D also. 3D related technique I will tell you. Don't worry now. The formula for mean is equal to sum of all elements of the matrix by total number of elements. And total mean and then axis wise mean also I mentioned it. This is my data, got it. Mean of every column, row and everything. Median, I mentioned it is a very important. Used for calculating or obtaining the mean of the entire matrix. Median is nothing but sorting the given data in ascending order and select the middle element. In the middle element means there is a difference will be coming if the number of elements are odd, number of elements are even. If the odd number of elements are there, center or middle element becomes a median. If the number of sorted elements are even, then select the center or middle of two elements, add them and divide it by what? 2. And that result becomes median. So I mentioned it. Here I took a matrix. Here I took a matrix related. Here odd number of rows and columns. Here even number of rows and columns. Data is completely shown here. Variance. See the formula variance is equal to SQR of square mean minus xi or xi minus mean. Anything you can write because anyhow we are writing square. By what? Total number of elements. Xi represents what? Each element of the matrix. So total variance, axis-wise variance is also there. Here total variance, axis-wise variance is also there. Standard deviation is equal to square root of variance. Variable name is equal to what? Numpy dot standard deviation of axis-wise standard deviation. And you are finding this and row-wise, column-wise, everything you have seen it. And standard deviation of this entire thing of things. Note, NumPy module does not contain mode function. Mode function present in where? Statistics module of Python. Mode gives you what? Highest frequent occurring element in the given object. Statistics as yes. This is my list data. Mode is found and L dot this element. Mode is found and 20 is found. Multi-mode will give you what? Equal number of 10 and 20 actually repeated. Both of them are equal number, both of them. And it is going to give you what? Converting this L1 into ND array. And I found mode and then what? Multi-mode. This is about statistics related operations. And if they ask about mode, don't tell mode is present in where? NumPy. Mode is present in where? So statistics module of it. This is comes under what operation, students? Statistical operations. So in this place, what is pending? 3D is pending. That I will work on it. I'll give a standard formula of it. We got it. Instead of making you confuse in the class, I'll give a clarity for you directly instead of making to confuse in the class. Did you understand? So next tomorrow class when I come back, I'll go for some more extra things like how do you sort the data? How do you sort the data of ND? How do you sort the data of ND? Row wise I will sort, column wise I will sort, matrix wise also I will sort it. This I am going to explain in the next class and plus some more miscellaneous operations I will tell you. Some more continuation part will be done. So don't miss tomorrow class. I'll stop the class now. Tomorrow don't miss it. Thank you. Carry on. Online students, you hold on, my dear students. If any doubts are there, I'll clarify it. Thank you. All the best. Students who are in the online, am I audible, students? Pavan Kumar Kakarla.
Hello, sir. I'm
Tell me,
audible.
Pavan Kumar, tell me.
I understood 1D and 2D, but 3D is like we have one more axis. Now axis is equal to 2.